Let us discuss the problem overlapping intervals. So the problem says that we have been given a collection of intervals and the task is to merge all the overlapping intervals. So let us understand this with the help of the sample input. So if we take this sample input here and try to understand it. So let's say one of the interval is given as 1 3, then another given is 2 4, then another given is 6 8, okay, and the next interval has been given as 9 10. So we have to merge all the overlapping intervals. Now what do we mean by merge overlapping intervals? So let us draw a number line first of all. Let's say 1, then I have 2, then let's say I have 3, 4, 5, 6, 7, 8, 9, and then 10. So if you will observe here, so what is happening is there is an interval from 1 to 3, okay, then there is an interval from 2 to 4, okay, there is an interval from 2 to 4, then there is an interval from where? There is an interval from 6 to 8, fine, and there is an interval from 9 to 10. So if you will observe in this part that basically this part, so these are overlapping intervals, right? Basically 1 and 2 and 2 and 4 are overlapping intervals because this part is overlapping, this part is overlapping between the both. So we have to merge them and combine them into single interval here. All the intervals in this problem that are going to be overlapping, we have to basically merge them. So in this part, what will happen? It will look something like this. After merging, it will look something like this. Because basically, what is happening? What is happening? If one is there, one is ending at 3, then 2 is ending at 4. So if you see that if you consider this as a starting interval, 1 and 3 as the starting interval, so in that case, what is happening? If we consider 1 as 3 and 1 and 3, 1 comma 3 as the starting interval, in that case, its ending is 3. So if the ending of the current interval is if the starting of the next interval is before the ending of the current interval, in that case I will say that they will be merging and I'll merge them up, okay. So that is what I'll do. So basically it will look like what, 1 comma 4, okay, then 6 comma 8, and then 9 comma 10. So after merging it will look something like this. Now let us understand with the help of next test case. So next test case is 6, like if let me copy this so that we can understand it better. So let us try and have a look at the next interval that we have been given. So in this interval, if we have a look at it, so basically what has been given? We have been given 6 and 8, okay. We have been given 1 and 9, okay. Then we have been given 2 and 4. We have been given 4 and 7 as well. And then we have like, this is what we have been given. Now in this, like how can we start? The thing is, will you start from 6 and 8? Then you will try to merge something, or how? So basically what we can think of is, we can think of sorting, right? We can sort the intervals, right? We can sort the intervals according to the starting point. So what will happen? First of all, 1 comma 9 will be there, then next up 2 comma 4, and then next up what will happen? 4 comma 7, and next 6 comma 8 is going to be there, okay. So these are the intervals that are going to be there. After these intervals are there, so let's draw a number line so that we can understand better. So let us say that this is the number line and the intervals are from 1 to 9. So 1 2 3 4 5 6 7 8 and 9. So in this case, I will have to return this in terms of a vector. So I'll say that I'll have an answer vector, and initially in that answer vector, I'll push 1 comma 9 as the starting interval. Okay. So if I push 1 comma 9 as the starting interval, then I'll say that I'll iterate from the next interval, that is from index 1. This is index 0, 1, 2, and 3. So from this index, if I iterate, so like will this interval come inside me? If this interval is 1 to 9, okay, if this interval is 1 to 9, so you can observe here that this interval is what, 2 comma 4. This interval is lying inside me, okay. This interval is definitely going to lie inside me, because if this is starting, right, if the starting of the next interval, that is nothing but, you can say, if it is represented by array of array of I0, so if the starting of the next interval is lesser than, is if it is inside me, right, if it is lesser than or equal to me, if it is lesser than equal to the current ending, in that case I'll incorporate it inside myself, and I'll say that now the maximum will change, right. Maybe let's try and understand this with the help of another example so that we can understand, because 1 comma 9 is taking whole of the space. So let's see one other case. So if we have, let's say, 1 comma 2, like let's say we have 1 comma 7, okay, then we have 2 comma 4 as well, and then we have, let's say, 9 comma 10. So in this case you can see that 9 comma 10 is not overlapping. Basically this and this interval is going to overlap. So how will you overlap them? Like from 1 to 7 this interval is going to be there, and the next interval, this interval is going to be from there. Maybe you can say that this interval will be going from 2 to 4, like this. Let's say from 2 to 4 it is going. So it is lying inside me completely. So I will say that in this case, this interval, like this interval will merge with this interval, right? But how do we check this further? Let's say that the starting was like here 7, right, and this was 4. So in that case, if from 1 to 4 I had one interval, right, if I had one interval from 1 to 4, and then the next interval I had from, let's say, 2 to 7, okay. So in that case, this would merge, right? Basically this part is there, so this would merge and the new interval will become. So that's what we have to do. Basically we will keep on pushing it into the answer vector, right? We will initially say that in the answer we will insert interval of 0, basically with the starting point, and then we will check, like we can check with the array dot back, okay. With the array dot back 0 will tell about the starting point, and array dot back 1 will tell me about the ending point of a particular interval, okay. Array dot back 1 will tell me about the ending point. So if it happens that a particular interval is starting such that its starting is lesser than the ending of the current interval, in that case I'll accommodate it inside me, okay. So let's try and understand this. So basically what I'll be having is I'll be having a vector. I'll be having a vector of vector int, okay. Let's name it as answer, because I'll be returning it. So I apart from this, what I'll do is I'll first of all I'll sort the given interval. So I'll say that intervals sort intervals dot begin, comma, intervals dot end. So I'll sort the intervals. Once I've sorted the intervals, so what will I do? Once I've sorted the intervals, so I'll say that answer dot push back. I'll push back what? I'll push back nothing but the starting point. So I'll push back the intervals of 0. Basically I'll push back the starting interval, and after I've pushed this back, so what I will do is I'll iterate through this every interval. So from starting from 1, so I start from 1, I is going to be lesser than intervals dot size, and then I will do an I plus plus, okay. After this part is done, so what I will say is that, like, what is my starting point? So as I said, answer dot back of 0, answer dot back of 0 will tell me what? Will tell me about the answer dot back of 0 will tell me about the starting, okay, starting of the last interval, okay. Will tell me about the starting of the last interval, and answer dot back of last interval that I've inserted, and answer dot back of this thing 1 will tell me about the ending of the last interval, okay. It will tell me about the ending of the last interval, okay. And once this part has been done, right, so this is what I will be focusing on. And after this, like, this will be the starting and the ending. So what will I say? I will say that if it happens that my current ending, right, if arrow dot back of 1, right, if the ending of the current interval, right, if the ending of the latest interval that I've inserted, if it is what, if it is greater than or equal to, right, if this ending is greater than or equal to the ith intervals is starting, ith interval starting is nothing but intervals of I0, right. If it is like this, if the current interval's ending is greater than equal to the starting of the next interval, right, so in that case it will merge, right. If it will merge, so in that case I need to say that answer dot push back what? In that case I'll push back nothing but, like, in that case I'll basically not push back. Basically I'll say that answer dot back, I'll update my back, because the starting point is going to remain the same, but back will update it. So back will be updated to nothing but maximum of what? Maximum of the ending of both the intervals. So maximum of answer dot back, okay, maximum of answer dot back of 1, comma what, comma the intervals for the ith interval, it's ending, right. So as I mentioned, like, ith intervals ending. Now what do I mean by that? I'll tell you this. So basically, suppose, like, as I mentioned, so suppose if these two intervals are merging, right, suppose if this interval and this interval is merging, so in that case, like, I will take the maximum. So in this case 7 is the maximum, so I'll take it. But suppose that was not the case here. Suppose in this case what happened was, if there was a 6, there was a 5, so I'll consider this 6, okay, because this is maximum. So every time I'll consider the maximum for the ending part, right. Like, I'll write a 1 here, okay. That is something that I'll be doing. And in the else part, what I'll do is, if they are not merging, right, if the interval is not merging, then I'll say that now I need to push back the ith interval into the final array. So I'll say that intervals of I is something that I'll be pushing back, and in the end I think that I can simply return the answer. So let's try and return it. Let's try and see what happens. Okay, we are getting a compilation error. So it is saying vector. Okay, yeah. So we are doing several mistakes here. So vector. Now, is there any other mistake? Answer was not declared, and I think now mistakes are covered. Let's see what happens. You can see that we are getting the same output. Let's try and submit this code as well. Okay, so you can see that our code was able to pass all the test cases. And now talking about the time complexity of this approach. So the time complexity is going to be nothing but order of n log n. Okay, because we are using the sorting approach. Thank you. In this video, we will discuss problem count number of possible triangles. Now, the problem says that you have been given an unsorted array of n integers and you have to find the number of triangles that can be formed with any three different elements of the array. So basically it says that they will give you an array which is unsorted. Okay, basically we will be given an array which is unsorted and we have to choose any three indexes I and j and k such that the sum of these three sides, like these 3 points, like such that ai, aj and ak are forming a triangle. Okay, such that these three are forming a triangle. Now what do I mean by this when I say a triangle? So let's say the sides are denoted by x, y and z. So we know that in a triangle the sum of any two sides is greater than the third side. So x plus y can be greater than z, this should be true. Then y plus x should be greater than z as well, and then y plus z should be great, like sum of any two sides, right? In a particular given triangle, not only this part but the sum of any two sides, like y plus z should be greater than x, then z plus x should be greater than y. So the sum of any two sides, the sum of any two sides should be greater than the third side. That is the criteria, right? Sum of any two sides should be greater than the third one, and that's how we define a triangle. Now let us try and see some of the examples. So let us say that if we have an example, right? Let's say we take an example like 1, 2 and 3. So like, are these three forming a triangle? No, they are not forming a triangle. Why? Because if you see, then 3 plus 2 is greater than 1. Okay, perfect. Then 3 plus 1 is greater than 2 as well. But the situation is 1 plus 2 is not greater than 3, right? 1 plus 2 is equal to 3, and that is the problem here, right? So sum of any two sides, as I mentioned, sum of any two sides should be greater than the third side. That's what the criteria is. So one of the ways that we can do it is that we can basically what use what we like let's say we have been given any unsorted array where we have been given 1 4, then 3, then 2, then 7 and 1, things like 7 and 4, whatever we have been given. So one of the ways that we can think of doing is that we can run three loops. Basically we can run three loops and we can find ai, okay, aj and ak, such that they are following the conditions, right? Such that they are following the conditions, such that what is happening, the sum of any two sides should be greater than the third one. They are following this condition. I have to find three different indexes every time by running three different loops, such that I, j and k are the indexes and ai, aj, ak are the elements, such that the sum of any two sides is greater than the third side. But if I do it using three loops, so I can understand time complexity would be order of n cube, and I do not want this. So how can I further optimize it? So let us try and see with this with the help of an example. Okay. So like if we have been given, suppose this example, the second example, that is this one, 6, 4, 9, 7 and 8. So if we have been given 6, then 4, then 9 and then 7 and then 8. So basically if you try to see here, so brute force will be order of n cube. But when can we try to better optimize it? Yes. Now if you see, what is the problem saying? The problem is saying that if I will repeat this word, the sum of two sides, sum of any two sides, right? Sum of any two sides shall be greater than the third one. Shall be greater than the third one, okay? It shall be greater than the third one. So I can say that it should be greater than the third one. So how can I do it? So if I see, I feel that I should sort the array. Why I should sort the array? And they have specifically mentioned that the array is not sorted. So the moment I sort this array, this question becomes easier for me. Why? Because let us say that this array has been given and I sort it. So the array will be what? It will be 4. Then I will have 6, then 7, and then 8, and then 9. Now if we observe here in this part, so we can get the pairs easily. Why? Because suppose if we are starting here, right? Suppose we are starting here, and suppose we start to see in this array, in this particular given array. Now if we have sorted it, so can we try to do it more optimally now? Yes, we can try to do it, because the thing here is that if I keep, let's say, a pointer I here, let's say I keep a pointer j here, okay, and let's say I keep a pointer a here. So basically I'm saying that I'm saying that like initially what you do is you start a pointer, like you keep a pointer k here, okay, and you always start a pointer from I is equal to 0. You start a pointer k from the end, and k will one by one keep on moving, okay. So a loop of k will be run. Then what you do is you keep a j here as well, okay. So j is equal to nothing but every time j is equal to k minus 1, okay, and k will start from the n minus 1, k will go till greater equal to 0, and I will start from 0. Then what I need to say is that if this is the circumstance, so now let's check. So what is 4 plus 8, right? What is 4 plus 8? 4 plus 8 is nothing but 12, and that is greater than 9. So I'll say okay, that's fine. So like does it mean that this is the condition that's satisfied? Because earlier what was happening? Why was I getting order of n cube? Because I was doing a lot of computation. So have I optimized the number of computations now? Because I have optimized actually. Why? Because if you will observe here, so the thing here is, like, the array is sorted, right? So currently the array of k is the largest. The pair that I'm considering among 4, 8 and 9, this element is the largest. So if the sum of the smaller two sides, if the 4 plus 8 is greater than 9, that is the sum of the smaller two sides, the sum of the two smaller sides in this triplet, that is 4, 8 and 9, the sum of the two smaller sides, that is 4 and 8, is greater than 9. So that means if I bring 9 to this side, so if I do 4 plus 9, so that is also greater than 8. And if I do let's say if I do this thing, let us say that what I have is another side pair would be what, like if I see 4 plus 9 is there, then 9 plus 8 is also there. Yeah, 9 plus 8 is greater than 4. So you can see, like, if I see for the larger side, if I take the sum of the two smaller sides, if it is greater than 9, so this if I include the larger side in one of the two sides that I'm taking the sum, the sum will always be greater, right? So that is the observation, that if a of I plus a of j is greater than a of k, so that means that this will definitely be a pair. This is definitely going to be a pair. Now you see, okay. So 4 plus 8 is greater than 9, so that means this will be a pair. So should I stop here? No, I can observe one thing, that if you see here, so like I can say that 4 comma 8 comma 9 is now a pair, as I've told you, because if some of the two smaller sides is greater than the larger side, then if I include the larger side in the sum, I'll always get this true. Now if you observe, so 4 7 and 9 is also one such pair. Why? Because if 4 plus 7 is greater than 9, okay, if 4 plus 7 is greater than 9, then also this is the case. Now if you see 4 plus 6 is also greater than 9. Now how am I able to say this? Because if it is happening that the current ai plus aj plus ak, if it is greater, like if current ai plus aj is greater than the current ak, okay, where k is fixed, this k will be fixed at a particular point of time, okay. K is currently fixed. So if it is greater than 9, okay, if these two elements are greater than 9, so that means what? That means that if I move my j towards the left side, if I move my j towards the left side one by one, so if this element keeps on decreasing, then also I'll get the same answer, right? I'll get the same answer, because like it will happen every time here, because if this element is greater, that means the for the others it will also work, because 4 plus 6 is what? 4 plus 6 is also like coming greater than 9. 4 plus 7 is also coming greater than 9, right? 4 plus 8 is also coming greater than 9. So that is why it will happen. So basically I can say that how many numbers I am able to add. So I can say that the amount of elements that I am able to add, let me just quickly do the indexing. So this is index 0, 1, 2, 3 and 4. So if I see here, so what is the number of elements? So I can see that 4 comma 6 comma 9 is one such pair, then 4 comma 7 comma 9 and 4 comma 8 comma 9. So basically if my j is standing at this 8, so 3 elements, and that is truth. That is the actual answer, because if you see, if I do j minus I, then what am I getting? I'm getting 3 minus 0. That means nothing but 3 elements, right? 3 elements. So that is why every time I get a pair such that ai, like ai plus aj is greater than ak, then I will do what? I will say that count plus or answer plus is equal to nothing but j minus I, and then I will say, then like I will say this, and then basically what I can say is that after this part has been done, so I can do a j minus minus basically, right? So that I can say that I have counted this pair. And like after this part, suppose it happens that I have not found a particular pair, okay. Suppose it happens that after some point of time, suppose my case is standing somewhere here. So suppose what happens, suppose for a certain k, suppose this thing happens, that a certain a of k is there, okay, and a of I is also there, and a of j is also there, and it happens that the sum is not greater than a of k, right? If a of I plus a of j, right, if a of I plus a of j is greater than k, then I'm fine with it. But if it is lesser than a of k, okay, if it is lesser, then I need to increase my sum. So how can I increase it? Since I was initially pointing to 0, so I can say that if I do I plus plus, if it is a sorted array and I is pointing in the initial part, so if I move towards the right side, then the a of I will increase, and definitely my chances of getting this sum greater than a of k will also increase. So that is how I will be doing it. Now let's try and write the code to see if it can get accepted. So let's see here. So basically what I have said is I'll be having a like three variables. So I'll be having int I comma j comma k. I'll be having the answer initialized to 0, and then what I will be doing is I will say that for basically int like first of all I'll sort the array that has been given to me. So sort arr comma arr plus n. I'll sort this array out, and then you simply move iterating. So like as I said, k will be starting from the end, so k is equal to n minus 1, and k is going to be greater or equal to 0, then I will do a k minus minus basically. And after this part is done, so I'll say that int like I'll say that I should be starting from 0 and j should be starting from k minus 1, that is from the back. And now what are the things that I need to check? I need to say that if it happens, if this thing happens that a of I plus a of j, if this is greater than k, that means that like if it is greater than a of k, sorry, if this part is greater than a of k, so if this is greater than a of k, so that basically indicates that I'm getting these pairs, right? So I'll say that count plus is equal to what, like count plus is equal to nothing but it will be nothing but j minus I. Okay, let me try and see if I look at this part here, right? So as I mentioned you, if suppose this thing is happening, if suppose that my currently my j is standing somewhere here, suppose my j is standing here, okay, and my k is standing here. So that means what? That means this part, all these part will come inside, right? Because if my j is standing here, so that means all these elements need to be counted one by one, okay? So that will be nothing but j minus I, and then after this part is done, so I definitely need to move my j towards the left side, okay? Else if it happens, right, so else like I have not written the while condition, so I need to write it that low I should be lesser than j, they should not cross each other. This condition I have not written, so let's quickly write it as well. Okay, so now it seems to work. Now I've closed it. So else if the current ai plus aj is not greater than a of k, then I need to increase my I, because if I increase my I, then the sum of ai plus aj will increase and it can become greater than k, okay? And finally, after I've done this, I can simply return what? I can return the answer here. Let's try and see what happens. Like I have written here count, so instead I should write answer here. Let us try and compile this to see if it can work on the samples. Okay, we are getting a compilation error. So yeah, A. So if they have given ARR, so I should write ARR here, ARR, ARR, and ARR. Okay, now it should work fine, I think. Seems to work on the samples. Let's try and submit this problem as well to see if it gets accepted. Okay, so you can see that our problem is getting accepted. Now talking about the time complexity and the space complexity of this approach. So what will be the time complexity? Okay, first of all, what will be the time complexity? So you must have understood j minus I, basically that many number of elements that many number of pairs can form with that particular set of I, j and k. Okay, now talking about the time complexity of this approach. So first of all, we were sorting, so it was n log n. Then we were doing what? We were iterating order of n time, uh, like the k, this was for the k loop, and then I and j are inside it, okay, while I is lesser than j. So that means at worst I'll traverse the complete array inside also for every k. So that means order of n again, so that means order of n square. So if I see the overall time complexity of this approach, so it will be order of n log n plus order of n square. So that will be nothing but the basically the overall time complexity will be order of n square, but you can add order of n log n part to it as well, and the space complexity for this approach will be order of 1. Thank you.